to another session here. This one's going to be focused on the AMETEK TDLAS based product line. My name is Michael Gora. I am a senior product manager with responsibilities for not only the TDL product line from AMETEK, but also the UV photo and other photometric technologies. So our sulfur measuring analyzers that are world-class and market share leading devices as well. So feel free to reach out to me in the chat. I'll be there for another hour after this session if you have any questions. So I'll go ahead and get us started here. So the 5100 series is this will be just a quick overview. But feel free again to touch base with me if you have any questions afterwards. The technology utilized in all 5100s is the tunable diode laser absorption technology, or TDLAS. In layman's terms, it's typically referred to as a laser. It's a light specifically tuned to a desired wavelength, is ideally free of any interferences from other components that are not of interest. And again, it's tuned specifically to a specific wavelength in order to make that analysis of that analyte of interest. Every 5100 series analyzer is a fully contained analyzer system. It does include the obvious, the electronics and the optics, but it also contains some sample handling and built-in verification capabilities. And I'll touch on that a little bit more in a future slide. The 5100 is certified for various worldwide hazardous locations. I'll touch on that as well. And it is designed to be either installed indoors or outdoors. The only caveat on an outdoor installation is we do recommend putting some type of sunlight protection or some type of shield to protect the analyzer from direct sunlight. There are 3 versions available. The first is the 5100. I would consider that our basic analyzer with the TDLAS technology inside of it. It's used to measure a single analyte of interest. It can measure one stream continuously, and it contains one laser and one cell. The 5100 HD is a more scalable and capable analyzer, meaning that it can handle more demanding applications that might arise. With the 5100 HD, we can measure multiple components inside one analyzer. We do have the capability of analyzing up to 2 different streams continuously because we can support multiple lasers and multiple cells all inside a heated oven. So that it's a little bit more robust analyzer in terms of addressing demanding applications that customers and end users may have. Then finally, we have the 5100P, which is a transportable analyzer, and that can again measure one component. And that can easily be moved around a plant. The background gas can be programmed at the factory and allow you to make measurements of, let's say, moisture at various locations inside a facility with just the one analyzer. And I will be, over the course of this presentation, going into a little bit more details on each one of these different configurations. So just a quick background. This is a basic block diagram, if you will, of how a TDLAS works when AMETEK's providing it. The electronics unit, you can kind of think of that as the head or a brain, if you will. It's going to control the temperature and the amount of current flowing to the laser diode. The laser then emits light that is split, and the first path will take it down into the sample cell, where it goes down, hits a mirror, comes back, and is picked up by a detector. And then that signal is then processed by the electronics in the analyzer. The other pathway from that split is to a reference cell, where we again are measuring the amount of absorption that is appearing at this end of the detector and processing that information inside the electronics unit as well. There are some demanding applications out there, and typically lasers are used for ppm level measurements, although they can be used for percent level as well. And when you start dealing with ppm level measurements, if you can envision a US football field If you go into one of the far corners and take roughly a 4 by 2 inch piece of grass sod out of there, that is the equivalent of roughly 1 ppm. If you look at the whole football field, that's what 1 ppm represents. So sometimes when there's very low levels of an analyte expected to be present in a sample gas, we need to extend our sample path length in order to get enough light going down there to be absorbed, then ultimately detected by our photodiode here. So we can offer various cells to increase that effective path length. What you're looking at here on the top of the left photo here is this is our standard cell, and typically what happens is the light from the laser goes down and it comes back one time, and that's picked up by the detector. And that gives us an effective path length of under a meter. But when we need to start looking at, again, very low levels or very low concentrations of components, what we want to do is we want to be able to adjust that path length sometimes by allowing the light to go back and forth inside the cell. This lower cell here is what we refer to as our short Harriet cell, and this is adjustable so that we can change that effective path length. And that's also shown over here on this lower section of the right hand photo. That again is the short Harriet cell. And if you look right above it, we've got a large Harriet cell. And what we're doing is we're effectively not only making this a little bit longer, but we're making it a wider diameter. And that allows us to bounce light back and forth along the perimeter of the lens that's in here and not have the light run into itself. So no interfering optics occurring inside here. So these are 3 different types of cells that we typically employ inside TDLAS analyzers that are supplied by AMETEK. I made a reference to it earlier. What we do when we split our signal, we send it down through a reference cell, and that reference cell is this housing right here, and it's typically a sealed ampule right here with some known concentration of the analyte of interest. And we do that to ensure that our wavelength is consistently sitting on that analyte. It's being absorbed, and you can see here some of that reference analyte is right here, and we're tuning our signal to make sure that we're staying on this wavelength of interest and not allowing our laser signal that's going through the sample cell to bounce around and start analyzing at a different wavelength or just get lost on us. So again, I made a comment earlier about the electronics being the brain of the analyzer. It's controlling the current and the temperature and allowing us to maintain this wavelength of interest right here. And because we have a known quantity and a known analyte sitting in this ampule, we know that we're sitting where we belong with our analyzer. And that's a pretty unique feature to AMETEK TDLASs. We've had that in place for over a decade now, and it definitely helps in day-to-day operation of the TDLAS analyzers. So I mentioned that we go into a little bit more details on the various models of the 5100. This is the 5100 NCM is what it was originally referred to, non-contact measurement. Since it has been more frequently referred to as the 5100 vertical, this is where we all got started. This came out in late 2006, early 2007. We started shipping the analyzer. We did introduce in this wave modulated spectroscopy. And for those that are familiar with wavelength modulation spectroscopy, it is a derivative of absorption spectroscopy that improves sensitivity and increases noise rejection versus direct absorption when we're dealing with demanding or harsh environments. So this was a way of ensuring we'd be able to look at those very low levels, ppm levels of analytes of interest inside sample gas streams. And the electronics that are found inside the 5100 NCM, we've been continuously updating and improving upon those But the important takeaway is that we haven't messed with the good thing, except to improve it. So we haven't continuously revamped these. We've been upgrading them to ensure better and better performance without making a major modifications. And that ensures that you're getting a well-proven set of electronics in your analyzer. The 5100 typically measures water in a background gas of natural gas. That's very common for this configuration of the analyzer. We also have done CO2 and H2S with this analyzer. We offer both local and remote interfaces. Local is a keypad found on the 5100. Remote would be via your laptop computer at like a desktop workstation, something like that. This is actually a variation of the analyzer we were just looking at. This is a AMETEK Zone 1 explosion-proof configuration, but we do also have the Division 2 and Zone 2 configurations available as well. And as far as power goes, we can provide AC power or 24-volt DC power to this 5100 analyzer. As I mentioned earlier, the 5100 HD was introduced a couple years later, and that was introduced to address the evolving user requirements. More users were needing to measure multiple components in a single analyzer, or they wanted to measure components found in different sample streams, and the 5100 HD gives us that capability. Because we can have two cells included in this analyzer. The 5100 HD also includes an oven, which allows us to maintain temperature well above most dew points and prevent water or liquids from settling inside the cells. But if that does happen, if water did manage to work its way into the system, analyzers you can easily clean the cells in a matter of minutes, and that can be done without any factory tie-in at all. It can just be done at the end user location. With the 5100 HD, we're capable of measuring water, hydrogen sulfide, oxygen, carbon dioxide, carbon monoxide, ammonia, methane, and even acetylene. And we've done all these. We have experience with each component that's listed here on this slide. Applications are not limited just to natural gas pipelines, though. Refineries, we have put analyzers there to measure oxygen and hydrogen sulfide. Gas processing plants, we see users measuring similar components there. Ethylene plants, we see more and more interest as consumers tend to buy more and more plastic materials. Ethylene production continues to increase globally, and that drives a need to ensure high quality product purity. And that is analyzed with the 5100 HD, looking at the interferences that may be present in there. Acetylene is monitored to ensure safe operations throughout that process as well. The maximum temperature oven, the maximum temperature supported by the oven inside the 5100 HD is 150 C. There are some excuse me. There are some instances where we have taken that temperature a little bit higher for some applications, but 150 C is typically our maximum temperature inside there. By having this oven inside, end users do not need to chill or cool samples frequently, and that excuse me. That reduces overall maintenance costs and requirements if you don't need a chiller or cooler, as well as not needing to do any adjustments based on a dry basis measurement. Hazardous area look certifications for the 5100 HD, again, multiple global certifications here. You see ATEX, IEC Zone 2 is mentioned. This picture is actually of an ATEX Zone 1 5100 HD with the purge unit on it. And just like the 5100 vertical that I was showing earlier, we can power this one with 120, 240 volts AC or 24 volts DC. And a pretty unique capability with the 5100 HD is that we can provide dual power because there are some installations where AC power can be spotty. They may have issues maintaining AC power, but they don't have enough DC power to keep a full 150 watt oven at temperature. So what they'll do is they'll put 24 volts DC on the electronic section, so the left side of the analyzer here, so that they continuously have communications with the analyzer and they don't have to worry about it going down and then rebooting. They can remotely access it by keeping that 24 volt power supply on the electronic section. But then on the oven section, they would have 120 or 240 volt AC power driving the heater. And if for whatever reason that AC power was lost at the analyzer and the temperature fell below a required set point, then by having 24 volt DC power and a remote communication, that alarm would be seen at a control room that could be located hundreds to thousands of miles away. The final analyzer in the product line is the 5100 transportable. Its formal name is the 5100P. It's a rugged, built-for-purpose analyzer. It's fairly easy to carry around. It weighs about 30 pounds. And it can analyze H2O and CO2 and a variety of background gases. We do have some standard configurations, but we've added some additional background capabilities as well. Hazardous location certifications are currently in place and available. I think that makes us the only portable TDLAS available on the market space that has Zone 2, ATEX, and IECX certifications, as well as CSA or North America Class 1 DIP 2 certifications. We stayed an 8+ hour battery life, and actual performances here at the factory, I tend to get much longer than that. I can leave the analyzer running overnight, and next day I come in and it's still running. But we guarantee the 8 hours with the analyzer. And this also has a line lock function in it that is very similar to what we use in the 5100 HD and the 5100 vertical. We do include on this one a sample conditioning panel as well. There are multiple options available here based on the pressure that will be seen by the analyzer. What you're looking at in the top left here is a full sample panel that can handle up to 250 pounds or 250 psig sample coming in here. We can regulate that with this analyzer or with this sample panel here. We do include a Genie membrane filter to drop out any particulates or liquids that may be seen on the sample gas. There's actually a drain valve right here. We can control the flow here, and you can view where your pressure is at right here on the sample panel. You don't have to have this if you know you're going to be bringing in let's say a 10 psig sample or less to the analyzer. Then you may not require this type of sample panel. We may be able to get rid of the pressure regulator and just include the flow meter and still include some of the protection of the cell by keeping the Genie membrane filter on there. We do have a direct interface with the 5100 portable sitting right on the front here with the keypad, but all the data can be accessed via USB port and pulled off of the analyzer, which can store up to 1400 measurements. So you can easily leave this analyzer running and pulling samples at a couple second sample interval rate and have measurements, or you can do a couple minutes sample rates and get an entire day worth of measurements that can then be trended and looked at via the remote software interface that we have. So as a quick summary here, the 5100 series of analyzers added to the capabilities that AMETEK already had in place with UV, and as mentioned earlier in Jung-Il Kim's presentation, quartz crystal microbalance for measuring moisture in natural gas. This is an addition that's been around for over a decade now. Very configurable. We can go with a variety of different lasers and bench configurations to meet various customer needs. And we can even offer different housings. based on maybe space requirements or whether it needs to be a fixed or a portable installation. As I mentioned, it's been available for over 10 years now. The 5100 portable, the one we were just looking at, that came out just a couple of years back. That came out in the summer of 2018. But the other analyzers have been around for over a decade. And then we do have a global service network involving direct AMETEK employees as well as very qualified distributors that can service the 5100s as need be. So with that, that's the end of the presentation. I will turn it over to John. Were there any questions out there, John?
One question, Michael, on temperature, but you addressed it when you were speaking on the 5100 HD. So you didn't answer the question on temperature and area classification.
Okay. Yeah, 150 centigrade is what we typically state as our max, although we can regulate that a little bit higher, or we can tune that down a little bit in order to reduce some of the power draw on the analyzer if it's just not required to be that hot. The goal is to keep the sample above its dew point.
Okay, and there are no other questions, Michael. So everybody, I thank you again for attending, and thank you, Michael, for the information on the TDLAS product line. We do have another session coming up at 4 p.m. Eastern Daylight Time in the U.S.
Actually, that's 2.
Sorry, it's 2 o'clock, Carla, excuse me,
Yeah.
2 o'clock on the combustion analyzer. So if you would like some information on that, please attend then. And thank you, everyone. Have a great rest of your day. Bye.
Thanks, everyone.